So we're not going to melt Azure at this point, are we?
Yeah, that's hopefully not.
Yeah, okay. Well, you know how it goes, right? You step into the demo world.
Yeah. So I have here a storage account, and you can see here this is a standard storage account, and I talked earlier. Actually, let's just go through the wizard and create a new one, and you can see all of the options that you have. I'm just going to type in storage, and you'll see here some of the options we have for third-party vendors. I talked about some of the other vendors that and actually they're down here at the bottom. That many different third parties who have solutions that can create SANs or SANs or network attached NASs sitting in Azure.
How about NFS? Do we support the NFS standard today?
Not natively with Azure Storage accounts, and we'll talk about another capability that's on top of storage called Azure Files. So not today yet, but we do have some. Party. Yeah, we have some third parties who can expose those storage accounts.
All right.
So in here, it's going to give me probably an error saying that the storage account's already in use.
I love it. That's one of the areas that we get a lot of times. Customers go, "Why is it telling me no?" And it's got to be a unique name because of that API access.
Exactly, and you can see that it's actually not region specific. It's actually .core.was in it. So sometimes, like when you create a VM, it'll be .east US.
Right.
So this has to be completely unique name. So this is the name of the storage account. That's the top level container that we talked about that has a 20,000 IOP throughput limit. So in here, there's two options. So general purpose V1 and storage V2. V2 is actually required to make use of that tiering capability I talked about. So we actually allow you, when you create a storage account, you can actually define whether or not this storage account is used for cool or hot. But if it's a V2 storage account, you can actually change it at a blob level. So for instance, if you had a 200 gigabyte SQL backup file that you wanted to just warehouse in a storage account, you could do that and commingle that data with virtual hard disks that are backing a virtual machine. So you can kind of mix and match what type of tier the files have. So that's actually a requirement to use this V2 storage account, and we'll look at how that behaves in the portal as well. So this is also where you indicate whether or not it's using that standard magnetic back storage or solid state storage, and this is going to dictate whether or not you're constrained to the 20,000 IO throughput limit or the much greater throughput limits, which will pull up the website and explore what those differences are here in a minute.
And do we have SLAs on top of those? I mean, are there guarantees? Because I think that's the other one that the SAN guys really push on me back is, do you have a guarantee for that throughput?
There's no guarantee for performance. Actually, no cloud vendor has a guarantee for performance. They're performance targets. However, if you're not experiencing the level of performance or throughput that we're advertising, we will absolutely work with you to identify what's going on or try to resolve any issues with that. So there's no SLA in terms of we'll give you money back, but we will help you identify what's causing performance slowdown. And actually, when I talked earlier about customers with 50 or more disks running in a single standard storage account, that would be the type of situation that we could identify very quickly. But sometimes it might take us a little bit more time to kind of dig under the covers and see what's going on.
Right. Okay.
So this is actually where I was talking earlier as well with the secure transfer required. This is where you can enable or disable the requirement to require some sort of SSL type encryption to be in place for accessing data in a storage account. in one final thing, just because it's on this page, and I wasn't planning on talking about this, but there's a capability called virtual networks. This is actually really cool. So when and this pacifies some customer security requirements. So this particular storage account is going to have a public endpoint. Test cloud 123 AAA or AA. .core.windows.net. So it will actually be publicly accessible. So
well, you're making me nervous.
Yeah, I can't retrieve any of that data without a storage account key or without being able to authenticate to Azure. Mm-hmm. So what this virtual networks capability allows you to do is basically disassociate or prevent public access to your storage account. So this would be a way to pacify the finance gods or the HIPAA gods, if you will, when, if you're in healthcare, to be able to to basically eliminate an attack vector, even though it would be a very low risk because you need those keys to be able to retrieve that data. But this completely cuts that off. So what this means is that you can actually make your storage account only accessible within a virtual network that's sitting in Azure. Mm-hmm. So then you can set rules even more specifically, saying I only want this storage account to be accessible by these 3 VMs. So you can actually create rules with with ACLs in your network to be able to restrict access to a storage account.
Okay, now we're talking. I like that.
All right, so I'm going to go ahead and just quit. Now I'm going to go back to my dashboard here. We'll go to Cloud Simplified and go to the storage account I already have created.
So while we're doing that, the cost of having a storage account, is there a cost associated with the storage account, or is it purely just for the storage I consume?
That's a really good question too. And when there is not a cost for a storage account, and there's actually not a cost for an Azure subscription. This is something that has come up, with customers very new to cloud, where they are concerned about setting up a development subscription for their dev team. There is no cost to having those resources sitting there or provision. It's the costs start incurring the moment you deposit data into it. So in the case of a storage account, rather, data would be the meter that would actually start running when you put something into it. With queues, obviously, if you put a message in a queue, is still depositing data. That would be triggering a transaction and
Gotcha.
Storage of data.
Gotcha. All right.
Yep. So in here, so this is actually showing me all of the blob containers, and like I said, a container. Think of this as folders in a file system. So I have here a container called test, and in that container, I have a PowerPoint deck that I was just sharing, and you can see right here is telling me that this is the default access tier for this particular blob is hot, and this is inferred because this storage account was created as hot access. So anything I put into it is automatically going to be metered at that rate.
Okay.
I can actually go in here and say edit. Edit metadata. Blob properties here. I actually wrong. Okay, so down here I can actually change this from hot to cool, and then we also, much like our competitors with the moving blocks of ice floating in the ocean, we have a tier of storage that's new. That's called archive.
Okay.
Archive storage for us is actually tape-based. It's actually funny to me to think that tapes are still the least expensive way to store data.
You're never getting away from it.
No, they're never going away. So
never going away.
So you can actually even move this to that archive tier, which is way less. I think it's 0.001 cents. I had to pull up the pricing page here.
Careful now, people are going to.
Yeah. I was going to say it's really inexpensive. Let's pull it up. So let's see, storage.
Love those ads.
Yeah.
Go big.
All right, so this is showing some comparisons for hot storage.
Yep.
You can see it's for the first 50 terabytes. This is for a month. Is 0.018 cents a gigabyte. Cool is 0.01, and archive is 0.002.
Wow.
So it's really
yeah, keep track of 0.002 cents.
So super inexpensive, but as soon as you move data to that archive tier, getting it back would actually take some time, to the tune of hours to a days, depending on how much data you're offloading, because we have to rehydrate that into your storage account.
Plus the retrieval fees, right?
Yeah.
Yeah.
Yep.
Okay.
Yep. So, and this actually is showing the operational cost. So I talked earlier about the performance being the same between hot and cool, but the I/O operations are more costly. So you can see the write operations for hot is 0.05 cents per 10,000. So it's a really insignificant component of the cost equation, but it does, there is a cost to it. And it's it's a penny per 10,000. So about double the cost for cool storage, but so that's more well suited for data that you plan on not touching or touching very infrequently.
Right, gotcha.
Yep.
We're gonna have to come back and do a show on the costs of Azure, and how they keep track of that at some point.
Yeah, that's actually a really good. We do have one queued up for Azure Security, so we'll talk maybe a little bit more about some of the components that exist in Azure to be able to secure very critical workloads such as the healthcare finance space.
Right on.
Yeah. All right. So this is a lot on kind of the basics of Azure storage. Assuming that our viewers might not have some of that background. So let's talk a little bit about some other capabilities that exist that customers can make use of. So first, I'm going to show something called Azure Files, and what this actually is a serverless file share in the cloud. So if you think about having an SMB share for in a Windows server for or in a Linux environment, running Samba. This is a way to be able to expose a container in Azure Storage to up to 5 terabytes today. That's that size will is planning on being increased here over time. But this is a way to create an endpoint that you can actually mount from your desktop at home or from servers running in Azure. This is actually a really good way to be able to put like a common location to put log files or configuration files, maybe images backing a website that you might want to offload into CDN once users start accessing it.
Yeah. What about but it's not real IO intensive supportive, is it? So
No, that's a really good point. So today there are some the throughput limits for Azure Files, and this is actually showing all of the limits for a storage account. So you can see that you have 200 storage accounts per subscription. 500 terabytes is the capacity for a single storage account. There's no limit to the number of files or blobs or tables or anything that's in the storage account. And there are some throughput limits, some network-related limits for ingress and egress limits for each storage account. This is where the 20,000 I/O operations per second comes into play. And down here, there's some limits for Azure Files. And you can see that the maximum IOPS today, this is again something that we're working to improve, is 1,000 IOPS. So this isn't something that you would use to mount on a SQL server, for instance, and putting your data on it. I mean, this is
bad.
Yes. Yep. So this is a really simple way to set up a share in Azure and be able to retrieve that data from multiple locations.
All
right. So that actually gets us into the final thing I want to talk a little bit about. All right, so this is just kind of an overview of that Azure Files I was just talking about, supporting SMB, 2.1 and 3. as well as our REST APIs to be able to access that data. So a pretty basic way to be able to share data across multiple machines or environments, and to access it. We created that storage account, if you recall my example, test 123 AA, so it would be that file, that windows.net / whatever the share name is, and that would literally be the SMB path to retrieve that.
Right, and there's no NTFS integration or Azure Active Directory integration today, right?
That is correct. Yeah. So right now there's no ACLs that that there's no integration with Azure AD.
Right.
It is a serverless share, so that's actually why there's some limitations today, and that connecting that up to directory infrastructure is a little bit more challenging when you don't have a directory controller sitting on the network. So it's but that is something that I know has been requested by numerous customers. So I don't. Hopefully, yeah. All right, so this gets us into kind of some real world scenarios. So we talked about storage, talked about all the different things you can do with it, talked about tiering and storage throughput limits. So what are some practical scenarios that you can leverage storage for? So this is actually something that sits on top of Azure Files. It's actually called Azure File Sync. So this is kind of a step one option. So let's picture a scenario. Let's say that you have a file server sitting on-prem today, and maybe users in Europe and maybe users in Asia as well as some VMs sitting in Azure that all need to access some file share of data. It doesn't matter what's on that share. Let's just say it's a bunch of Word and Excel documents as a simple example. And typically what you would do in an on-premises environment is use SAN replication, have SANs in different locations, and maybe if you have some sort of point-to-point connection between your offices, you'd replicate that data.
You're starting to give me a headache.
yeah. So when you think about and it gets expensive really fast, because if you have hundreds of gigabytes or terabytes of data, you have to have that in n number of locations, and also to the level of performance that the users in those remote locations are expecting. If it's solid state, high performance disks, you have to put that everywhere. So this is a good way to solve some of those problems. So you can actually have data. Your golden copy of data actually resides in Azure Storage, and the benefit there being, as you saw from the costs I pulled up, is very inexpensive. And you can have a Windows server that you put a piece of software on that will actually pull down all of the metadata of this file share sitting in the cloud. And by that I mean, doesn't necessarily pull down all the files. So if you have 100 terabytes of data in Azure Storage, it's not going to pull down 100 terabytes onto this server. It's when you install the agent on a Windows VM, and by the way, this Windows VM doesn't necessarily have to reside in a branch office. It could be in an Azure data center or some other co-location facility. The only requirement is that it needs to be a Windows server. So you could allocate, let's say you have 100 terabytes of data. You could say I want a terabyte of cache on this server. So what it will do is it will pull down all of the metadata, so users hitting this local server will see all of the files that are stored in this golden copy in storage. And when they access this data, or as they access this data, that's when it's pulled down, and that's when the cache policy here comes into play. So basically, this machine will just store and warehouse the most recently used data, as opposed to all of the data sitting in here. And you can also do the same thing, having multiple other servers in different locations. So like, here, this is depicting maybe another office in the headquarters that's doing the same sort of thing, pointing to that single golden copy of data. And the benefit here is you are paying for storage in the cloud once. And yet there are there's some local disk being used on these servers here locally, but it's not to accommodate the entire amount of data that you want to store.
Right. Okay.
So this also has another capability that you can designate a storage account in another region. So if you had a branch office in Europe, as this is showing, instead of this server having to traverse the pond to access data in the East US, you can actually have our storage account in the East US replicate to a storage account in Europe.
Okay.
So we will actually keep those two storage accounts in sync and allow you to point, to the storage account in Europe with machines that are more physically close to that particular geography.
I got you.
So, yeah. So this is something native to Azure. Azure File Sync is what this is called, and let this build out completely. So the cool thing about this, like I said, you can access this over SMB, as well as using the clients that you could put on any one of those servers. It also allows you to integrate with Azure Backup Vault, which means that we can actually natively back up those shares for you. So this is a serverless, SANless way to warehouse data and share it across different geographies or different regions.
Oh, that's cool.
So the limit with this today is that this is actually hinging on a singular storage account, which has a limit right now of 500 terabytes, as well as a throughput limit of 20,000 IOPS. So in my customer's example, let me jump over to a whiteboard here. So in my customer's example, they had a bunch of SANs. Let's just quickly draw that. So this is actually, in their headquarters. And these were solid state. These are really expensive disks. These are, I think, some EMC SANs that were always running hot. They were always running out of storage. And this customer was actually building, they actually build engineering software. So think, computer-aided manufacturing, computer-aided design type software. And sitting on those SSD volumes was test data that they needed as part of their build system to do automated testing against their products. So this was, sitting somewhere in Michigan. They also had another one in India, and they had another one in Europe, and they had the same sort of setup or configuration, the same size SAN in each one of these locations. And they actually were replicating that data, back and forth. And they had developers that were sitting here that would be able to access that data, locally without having to go across the. So these files were huge. A typical file was I think like 20 or so gigs, and they had some that were in hundreds of gigs. These were huge engineering models, and they used them for like I said, testing their product. So there was critical data for them to be able to use as part of their development workflow. So also sitting here in the headquarters, they had a bunch of build servers. So these were like I think they were like 64 core, with I think they were 128 gigs of RAM. So these were pretty high-end boxes, and they had a ton of these. So a developer sitting in India would basically say, okay, I'm done with, I'm going to commit this branch of code, and that branch of code would actually go to one of those build machines that would actually go out and retrieve, some amount of data from the SAN, and build and perform a bunch of automated tests. So did
it take them a lot of time? Because I'm seeing just a lot of time inherently in geographic dispersion as well as
time and cost. This cost them a boatload of money because they had. And they made their storage vendor very happy. I'm sure.
It made their network provider very happy. I can tell you that right now too.
Yes. So the thing that they really wanted to address was, and the reason why they came to us was to replace these servers. These right here. They wanted to move those into the cloud somehow because these were getting aged and. Just to put it into context, it would take about 6 hours to build and test one of their products. So the problem was that, during an 8-hour workday, that left 2 hours for these guys, mostly in India, to, be able to pull down that build and look at the test failures and try to fix it.
Yeah.
So
it's a lot
their
of team
goal,
time.
yeah, their goal was to drive down that build time.
Yeah.
To get to allow their developers to have more time to do work during a workday.
Gotcha.
And they didn't want to have to buy a bunch of massive hosts to be able to make VMs that were of
Right.
very significant size.
Right.
So the problem with just lifting and shifting so first off, Azure can accommodate these VMs no problem. I mean we have VMs that can go up to 128 cores, no problem there. The problem was getting hundreds of terabytes of data to be accessible by these machines. Mm-hmm. So one way that we could have done it is we could have put those in Azure, and we could have set up a tunnel and actually had these machines talk to that solid state storage there. This customer today has VPN access to Azure. So this is a 1 gigabit line, and they're increasing this to 10 gigabits with ExpressRoute. But over a 1 gigabit pipe, pulling down 20 gig files, we're not going to decrease the build time. We're going to be increasing it significantly.
Yes.
So how do you solve that? So what they did is they had one of our many partners that we have who have solutions sitting in Azure is a company called Nasuni, who has, and that's actually, I use red to kind of denote all the stuff sitting in Azure. UNI. So this is our Nasuni appliance, and this actually pointed to multiple storage accounts.
Okay.
Just say A, B, C, N. And each one of these storage accounts has a throughput limit of 20,000 requests per second. So the advantage of spanning across lots of storage accounts is that we can effectively make this expose iSCSI LUNs that are really fast. And so now we can put these VMs in Azure, mount that storage, and these VMs can actually can access data faster than they could from the solid state stand they had on-prem. So using the internal Azure network, so this is a VM in Azure, this is a VM in Azure. This is all going over a private network in Azure. Mm-hmm. That this data transfer was actually better than they could get on-prem.
So, and not only just in performance of the channel, right? You also are scaling past our 500 terabytes in the storage count limitation. So now we're talking petabytes, right?
Exactly. Yep.
Oh, that's cool.
So now the other thing they can do is they can put another one of these boxes. You and I, they put another one of these boxes in India, mm-hmm. Or in other regions, and Nasuni has the capability of replicating that data much like Azure File Sync natively does. So they can do the same sort of thing, but they just replicate. This is actually a optimized replication that just replicates changes and differential. So you're not taking a 20 gig or a 20 gig file and transferring it across the pond. You're just transferring the bytes that change. So it's
okay. So it's what we would normally talk about, like block level changes. We'd only replicate those, right? That's the most efficient way of getting it across.
Yes,
nice.
Exactly. Okay. And they can also, so let's say maybe there's only some data sitting in here that they want to replicate to storage accounts sitting over here. So we have this is just representing data sitting in that Nasuni appliance, and mm-hmm. so we can actually just replicate just the engineering data they need for testing. And now they have the advantage of deploying VMs here locally as well that can access that build data. The engineer sitting over in a picture of an engineer here, the engineer sitting in India can access can access that data very very expediently as well.
Oh, nice. Okay, yeah, that's a great example. I love that. So, did you have a cost savings that they probably came along with this package? Because the finance guys, they're always going like, well, how much money did you save me? My wife, I've saved you this much.
But I had to spend a little bit. So
yeah, that's right. I had to spend a little bit.
So Nasuni is not free. So there is and they have the way that their product is licensed is by the amount of data that you're actually storing. And Nasuni actually has a really interesting licensing model where you don't actually pay for these virtual appliances. So these are VMs, so there is a cost to running these in Azure. There is no licensing cost for standing up these elsewhere in the globe.
Okay.
So
right.
they charge you for the raw data that's actually being, if there's, 200 TB of data here, that is actually where they establish their costs.
Okay.
So you can deploy these all over the globe, and the cost will remain the same. So this is actually they want to deploy one of these to Europe or even in California. They have a development office. They still have a fixed cost here.
So is the cost then also included for the replicated site? Since that would essentially be a duplicate?
So the cost is just based on raw storage that they actually want to back with this appliance. So,
gotcha. Okay.
And Nasuni has a very good sales force that can work with customers to give them the best deal for the amount of data that they anticipate storing in Azure.
So you talked about regional replication.
Yeah.
How does that work? So going back to my tinfoil hat friends, they're going to ask, okay, you've got this appliance that's moving data from one geo to another geo. Where is that being traversed?
So that's a good question. So, all right. So, replicating from Nasuni to Nasuni, you can actually connect the private network that's in India, the private network that's in the U.S. using VPN tunnels within Azure,
okay.
and that has whenever you say VPN, you think about appliances or devices. They have to create IPsec tunnels between. We can do that from Azure region to Azure region and make it very simplified to a customer. They just have to deploy a VPN endpoint in both locations and wire them together. So it's done virtually at a software level, and more importantly, it's done securely and it's done over our network. So we have one of the largest privately owned fiber networks in the world, and that data is actually traversing cables that we've either laid, we've either purchased, or that we directly have leased. So it's our cable that we refer to as our dark fiber that's inaccessible from the public.
Wow, that's a huge benefit for them then. That's great.
Yeah. All right, so I know we've talked a lot about some different scenarios. This real world scenario. We went to the portal, and I know that you came from the healthcare space prior to Microsoft, and you talked about you and I were chatting earlier about some scenarios where particularly with medical imaging, where this is a fairly complicated problem to solve. Talk a little bit about maybe.
Yeah, so that's a great segue there. So PACS imaging, it's the bane of every healthcare IT individual because of the cost of storaging these diagnostic images, right? So you bump your head, you go in for a CT scan or a PET scan. Those images are massive, right? So there's all this diagnostic data that goes along with that image, that slice as they call it, when you go through the machine. So, and by law, they're required to hang on to it for essentially forever, right? So it's one of the other things that a lot of IT guys don't want to hear is, no, this data truly has to stick around forever, right? So as you were describing this scenario here, one of the other types of workloads that, I could see customers coming to us with and really, asking for our help, but having some stickiness to the on-prem side of it is the PACS imaging system. So the Fujis of the world, the McKessons, the GEs of the world. But if that Nasuni head is like that and it's able to do that kind of performance level for these types of guys, I definitely see that because PACS imaging has that nearline requirement because you have radiologists that are looking at that data as a service to either that hospital or other hospitals. It's a trend that's coming along. And, they need that data very quickly for the patients that they're reviewing. But at some point, that data's got to get offloaded. And typically they go into very massive, very expensive storage frames that you're talking about because at some point they may have to pull that data back for another review or maybe that patient has a follow-up a year later and they want to pull that image back and just double check, they got everything correct, the diagnosis is right, or they do a follow-up imaging, they want to compare the two. So this is going to be like a really great solution to sit down with my healthcare friends and talk to them about how they can get past this packed storage component. So thanks for sharing that, Ryan.
Yeah, no problem. And so I think it's good to kind of highlight some other scenarios that this can apply to our viewer audience, and hopefully this was informational. It started off with some basic stuff, kind of progressed towards some more advanced topics. The purpose of this is to provide you, our viewers, with meaningful and insightful ways to be able to leverage the cloud to solve problems. So hopefully we did that. Definitely let us know through comments and cloudsimplify.io website. We'll provide some show notes and a blog post, as well as some follow-up details and some more information about how this architecture was deployed at a customer I was working with. And also you can monitor that for any other anecdotal updates from Matthew or myself. So thank you all.